This is a dust collection quick connect adapter allowing you to easily switch between the tools in your shop. This one is 3D printed and I designed it in Fusion 360, but it is not perfect. I think we can do way better. So in this video, I'd like to show you how I go about creating one that's even better than this. I'd like to show you my process for inserting neodymium magnets with 75% accuracy as well. And I screwed up. These should be positive, negative, positive, negative. And we're also going to throw some tests at these and see how durable they are. So stick around. Embedded neodymium magnets. It goes north-south, north-south. And that means that this connector can be flipped upside down and rotated one position, and it can connect to the one that's down in this position. That's a pretty neat system. This one also has a thread, so it can be threaded in to this hose. And that way there's no need for a clamp of any sort. Now these are commercially available. They don't have the threaded setup. They typically use a clamp, and they usually show quite a few more magnets, and the magnets are not embedded directly into the part. There isn't a lot wrong with this connector. I just think that we can overall do a better job. But first, what I'd like to do is show you how I designed this one in Fusion 360. So first up, we're just starting with a basic cylinder. And I want to make sure the diameter is slightly less than the inside diameter of the pipe. So 124 millimeters. We can extrude that, and I'm going to go in both directions in this case, and I'm going to go to a 65 millimeter distance. Now we can create a coil from one of the faces, and then we are going to go with a height of -65, a section size of, let's say, 6 millimeters. It looks something like that, and we'll create that as a new body. Now we'll turn off that thread and extrude. Let's say 10 millimeters up and 10 millimeters down. And now we can join those parts together. But what I like to do on my threads is remove that very sharp leading edge. I don't think that that's a good idea. And if you look at some parts that are made from metal with big threads on them, you'll notice that they have kind of the same thing. That lead-in edge is typically removed or filed off, and that way you can enter much more gradually, and it's also not prone to getting damaged. We'll project the intersection. I'll just draw some rectangles around those areas of the thread, and then we can extrude. And again, symmetrical. We'll take care of both at once. We can cut into that. So the magnets that I have are 15 millimeters by 3 millimeters. Try to constrain a circle. You can right-click, pick circle or arc tangent, and then you can pick the tangent of both. So I want to be maybe 3 millimeters away. Another 3 millimeters. And we'll put a 15 millimeter radius on there. Extrude the basic circular shape, and including the center, and I'm going to say 7 millimeters. Then I'm going to extrude again with that separate shape. Again, 7 millimeters. And I'm also going to extrude the circular shape. And we'll do the embedding as well. And the embedding will be in starting probably around 1 millimeter up, I would think. It's 3.8, 2.8, 3.2. And I'm going to go back and I'm going to change this to 15.15 just to give a little bit of clearance. Okay, there we have the pocket for the magnet. And I'd like to pattern it around 6 times rather than 4. I think that's probably a better idea. I'll add a chamfer at the back of 4 millimeters. Then I'll go back to the original sketch. We're going to go with a 2 millimeter wall. Cutting through the entire part. So that is pretty close. We can add the little finishing details like some chamfers on here. I think that looks pretty good, and I think it's probably a little bit better than the one we created the first time. Now let's take a look at that one and see where the issues are and what we can improve on. If we have a close look, we can see that we have some trouble on the overhangs because of these curves. So these are getting very close to horizontal, and these can be a little bit sharp, and I think that they would probably end up ripping that dust collection hose. I mean, maybe not initially, but over time. So I definitely want to address these threads and the thread shape. The next thing is I don't really like these flange pieces hanging way out. If we look at the professional version, it has a piece that's going all of the way around, which is probably a little bit more reinforced. I just picture this being dropped on the corner. So I want to address this. Now I only have these magnets right now, so I'm not quite sure how I'm going to solve that problem yet. We'll have to come back to that. I think we can get away with something that's a few threads shorter, or at least one thread shorter. That'll make it easier to insert into the pipe as well. Sometimes a flexible hose needs to be supported too, so I think it might make sense to integrate a loop or a hook of some type into this, and that way it can be supported directly up to the ceiling. I do like the finished look of these embedded magnets, but I don't like pausing the print and having to insert the magnets in there. Luckily, they are attracted more to the build plate than they are to the nozzle, and that way the magnet doesn't leap up and get attached to the bottom of the nozzle. That works fairly well, but I think instead we're going to go back to what the professional versions are doing and embed the magnets from this face using super glue. For the thread design, it really needs to look something like this. We need to come up on a 45-degree angle, curve around, and then we can be flat if we want to, or come up on that same angle as well. For the magnets, I think we still need something that's fairly powerful. I don't want this coming apart on its own. So what I was thinking was to change the magnets from a circular magnet to a rectangular magnet. And I've never actually used rectangular magnets, so I don't know if this is going to work, but we are able to get the thickness down. If we look at the flange from the top, we'll have all of these rectangular pieces, north-south, north-south. For the overall length, we just want to make sure that it's not too difficult to get into the dust collection hose, but also if we ever need to take it out, we can get that thing out there pretty easily. The final connector will be available for free for each of you guys to download if you want, and I'm also going to make the Fusion 360 file available for you if you want to modify that size. So we're going to make this parametric also. And for the hook or for the hole, that's pretty easy to integrate some sort of a loop with a hole into the design. So let's jump over to Fusion 360 to see if we can account for each of these. So I'm going to set up a list of just basic parameters like the overall size. I'm going to have thread pitch in there, the diameter of the pipe, for example, and all of the magnet properties. And that way I can easily modify them later on once this is all set up. If I want to change it from a 5-inch pipe to a 4-inch pipe or a metric pipe or whatever it is, I can change all of those dimensions really easily and not have to go back and change all of these things individually and have to remember where I referenced which numbers. The last time that I did the thread, I went right onto the top and I aligned the center of the thread or the coil with the outside diameter of that cylinder. And I think it went out a little bit too far because we were getting that kind of horizontal section that was really difficult to print. So instead, what I want to do is just bring it in a couple millimeters, and that way we don't have quite that horizontal section. It's getting close to more of the center or midpoint of that arc, and that's going to eliminate some of that problem. In the drop down near the top, we can change it from the amount of revolutions and the height to the amount of revolutions and the pitch. Down below, we'll select the parameter for pitch and change it to the negative direction so it goes down. Now we can see that the coil section is not quite central on that cylinder. We will deal with the ends of the threads in the exact same way, but I'm going to be doing chamfering, and that's going to give us that 45-degree angle leading up to it. And I'm also going to chamfer the top too, just because I think it's going to look better. It isn't really necessary in this case though. Now what I didn't do last time that I wanted to do was hollow out the threaded section. And the reason it didn't work, I think, is because I went ahead and added the flange on first. So this time I'm going to hollow out the threaded section first. That way the outside remains a consistent thickness. It'll help us to get a better result, but it'll also save a little bit of time in printing and a little bit of filament as well. Now we can just extrude the flange up, and then we'll add the chamfer on the bottom of that just so that we have a nice transition. And then we can draw a sketch which has the magnet cutouts that we want. In this case, I'm going to do a rectangular cutout. I'm also going to do a cylindrical type of cutout, and we can just choose between both. And I think what would be a really cool option to have in Fusion 360 is a little checkbox option to flip between different selections. I don't really know of a way to do that in Fusion, but maybe you guys have an idea how to do that. The last thing to do is to create that hook, and what I'm going to do for that is create a sketch and create two arcs. I'm going to have them concentric and just spaced far enough apart that it's going to be pretty strong when it's 3D printed. I'm going to revolve them around an axis that's just a little bit in from the outside of that flange, and that way it can die into the actual flange and still be fairly strong and still look pretty good, I think, as well. With a few little finishing touches and a few fillets here and there, I think this is pretty much ready to get printing. For this part, I'd like to try two different materials. I want to try PETG because I think with this wall thickness, it's going to be pretty impact resistant. And I'm going to try TPU for the AMS. Both of them are yellow, so it should be a pretty cool comparison between them. I like to print most of my parts heavy duty, or as heavy duty as I can, so there's going to be very little infill in this, only really where the flange is going to be, and the rest of it is going to be pretty much solid. I hope you're enjoying this type of content. Make sure that you like the video and subscribe if you are. It really helps to support this channel. Let's get back to it. There's something about holding a part in your hands that just helps with the design process. So normally I don't do this, but I printed a small scale version of the finished product. This is just out of PETG, gray PETG, and although it's not full scale, I think it still will help a little bit. The threads turned out perfect. Look at the start of that thread. It looks really good. And then the threads themselves, compare them to what I did before. It was really rough at the bottom and still rough at the top. We don't have that problem anymore. These threads look really good. Even though this is half scale, that's still big enough to get a wire through there to hold this up from the ceiling. This can be easily hung using one loop or maybe holding it in position from multiple points using more than one loop. I don't know whether that's needed, but I thought I would add that feature anyway. I think I'm going to have to change these from being rectangular back to circular because I just got the magnets in, and I have some rectangular magnets on order, but I don't have them yet, and I'm not sure if they're going to arrive on time. So what I have is these 5mm by 5mm. So I'm going to stack them inside there, and hopefully that increases the attraction. And I also have 10 magnets. These are pretty small, but it does allow the rim to stay pretty tight, pretty small in comparison to what we had here. And the idea is that if this were to be dropped on one of these, it could potentially break. You have some extra weight of the pipe as well. It's quite tight and pretty robust. And if I print this from PETG, I think it's going to be able to flex a little bit. ABS would be another good choice, but I was thinking also to print one in TPU, not the ordinary TPU, but the TPU for AMS, which is quite a bit harder. One of the benefits of the cylindrical magnets is that we can just use a drill bit to ream out the holes. So if these holes don't print the exact right size, if you don't calibrate your filament perfectly, it might not fit properly, but with a drill bit, and it would be a 5mm drill bit, these would be able to press in with super glue. So that's a really good option. I think probably the cylindrical ones is the way to go. I just got these from Amazon. They were one of the cheapest options. Before I get the print started with the TPU for AMS, I've switched over because you can't use the bamboo super tack for TPU. So I've got the high temperature plate. Okay, both prints have finished. Here we have the TPU for AMS. So it's going to be a fairly stiff version of TPU, but it still has a little bit of flexibility in it. So that's going to be pretty impact resistant, I think. And here I have just standard PETG. It's not even the high flow PETG. I've had this hanging around for quite a while. And I realize now that I probably should have done a better job. Wow, that's very bright. Of calibrating this filament specifically. I used the calibration that I already had for the green PETG. I thought was going to be the same, but you can see that the seam needs improvement. Both of the prints look pretty good with the exception of the seam on the PETG, and the TPU for AMS has these little tiny, what looks like vibrations, but I'm sure it's not. It's probably just a setting that I need to adjust. It almost looks like a bit of under extrusion, but in any event, it's not really important. What is important is that these things work. I would say the holes are just a tiny bit undersized. So now I can take a 5mm drill bit. I'll just try one first. Okay, yes, perfect. I'm gonna go ahead and drill these, but I'm gonna do it at the drill press just to make sure that I get the depth correct. So I don't want to be wasteful with magnets. I mean, these are pretty small and fairly inexpensive, but if I don't need to use two stacked up, then I don't want to use two stacked up. So what I was thinking is to push one layer in to be flush and then test them out. And then if I need another layer, then I will add it, and then these seem pretty snug. I don't think there's going to be a problem with them coming out, but I can use super glue on the second layer if I need to. And I screwed up. Great. Okay, it's time for some serious firepower. I have these magnets here. I'm going to remove the sections in between. Oh, wow, that's going to be powerful. I can't even get my rubber glove out from in there. See if I can pull these out with powerful magnets. The funny thing is, the power of the magnet, geez, look at that. Look how it's moving that little magnet there, dancing around. Look at this thing. It doesn't seem to want to pull this one out. So maybe what I should do is just drill a small hole from the bottom and push them out very carefully and hope that nobody notices it. Oh, 3 of the magnets are fine. Just one. I just need to remove this one. Not bad, but I think I'd like an extra set of magnets in there. So I wasn't quite happy with the magnet size, even though I doubled it up. I think it's plenty good, but I'd like to be a little bit stronger. So I went to a magnet calculator, plugged in a few different dimensions, and came up with an 8x10 cylindrical magnet. So Amazon did not have a great price on those, so I went to AliExpress instead, and I've got some on order. They're a much bigger quantity and a much better price, but they won't be here for this video. I've also changed the amount of hooks that we have on here. There were just way too many hooks, and I've also changed the thread size just to refine it a little bit more. It's just a tiny bit larger in diameter. I went ahead and reprinted it. I've got a metallic filament this time. Look at that cool shine on there. So there it is compared to the original one we printed. Now I should admit that I've been teasing you guys. This is a pretty cool feature I just learned how to do. In Fusion 360, you can export as an augmented reality file, and this is what you get. You get a part that you can move around. You can change the scale if you want to as well, and compare it basically like it's real life. I actually even want to grab this because it looks like it's real. I think this is going to be the future of design, because you can go to a customer, you can show them exactly what they're going to get, or if you're building something in your own shop or for your home, you yourself can take a look and put it wherever it needs to go, on a build plate or on a machine or on your bench top as well. Pretty cool system. I think with a VR helmet, this would be even more immersive, and you could really move this thing around, get an idea of whether it is exactly what you want before you produce it. I'm not going to try and break these, but I'm not going to try and break them either. I want to test these out and see if they can take a bit of abuse. That's 3 drops. And the green one, just a little bit of damage on this corner for the green one. TPU for AMS. You can see there's a few scratches just on the corner there. Yep, right on there. And the PET G. Yeah, again, all the magnets are still in place. And again, just a few scratches right here. Everything else is perfectly intact. So I think any of these materials will work perfectly fine. I actually really like this semi-flexible, somewhat stiff TPU for the AMS. It's a little bit more expensive than ABS or PET G, but it could be pretty useful where you want a little bit of flexibility, but not too much. I'm going to have 6-inch, 5-inch, 4-inch, and also 2.5-inch sizes available in the description below. They are, as usual, free. And if you guys want to make any changes yourself, I'll have the Fusion 360 file in there as well. So I'm pretty happy with how this turned out. It definitely needed the larger magnets just to make sure that it can never come apart. You have to twist it or you have to try and pull it apart by hand. But this on its own really isn't that useful. You can definitely connect 2 corrugated pipes together, but one end needs to be on a machine and the other end should be on a corrugated pipe. And that means we need some sort of adapter for different pipe sizes as well. So in the next coming days and weeks, I'm going to be adding those to that same link down there below. So check that out if you're interested. There is another option, of course, the obvious, just cut a small section of this corrugated hose. It would look something like this. And I think that's an okay solution. Personally, I'm not a huge fan of it. I would rather it all be built in. And for me, eventually when I reprint this in the proper Makita colors, I'm going to build in the magnetic connector there. And I finally came up with a proper name for this. I'm calling it the MagMate. I want to say thank you to each of my patrons for making these videos possible, and thank you for watching. Take care, and we will see you on the next one. So this is what it looks like. I haven't printed the mating piece yet, and that's not good. This is a left-hand thread. That was kind of a silly assumption. So this needs to thread on rather than the right-hand direction. So let's go ahead and make a new one. I'm going to try and get this apart and scavenge those magnets out of there.